But a phase shift, a vertical translation, is called a vertical displacement. You'll see that wording here. So I'll give you a second if you want to jot that down. All right, so let's move on to this example here. And this is where we're given a graph, and we're asked to basically determine the equation of the graph. Now, and granted, this is trickier. This is trickier than graphing something you're already given. What we want to do here is we want to determine what the values are for A, B, C, and D, and then we'll plug those into the equation. Okay, first of all, we have to determine whether we're going to create a sine graph or a cosine graph, because remember, they're both sinusoidal. They both have the same shape. Lots of times in the question, you'll be told, make a sine graph equation for this graph. And so then it's easy. Okay, we've got sine theta, and I'm going to determine what the parameters are and then build my equation. So we're going to make this a sine. Okay. All right, so on this graph, it's really handy, actually. They remind us what A is. The A value is the amplitude. And so you can see here in purple is the midpoint, and you'll have to determine that, just given a graph. They won't give you all of these parameters. This is sort of like a bridge here to help you. But you have to find the middle. So here's the top, it's 3. Here's the bottom, -1. That's 4 units. So 2 units down from 3 is going to be your center line. So what's the A value here? Now remember, this is 1 unit. 2 squares is 1 unit. So this is 1, 2. So A is 2. Okay, A is 2 units. Okay, very non-confident answers there. Okay, so A is 2. What about B? Okay, B. Well, to find B, you don't just look at the graph. You kind of have to do some calculation here, right? Remember, the period length equals 2 pi over B. So we might actually have to do some stuff on the side here. What is the period length here? From start to start. Now, you don't have to go from here to here and do this subtraction of these two. You don't have to. You can. It's not going to be that hard. But what you could do for the period length is you could start at 0 and say, this is the start point. I need to go to this end point. So what is the period length from start to finish of one complete cycle? It's pi. Okay? Does that make sense? 7 pi over 4 minus 3 pi over 4. That's another way to look at it. And that, of course, comes out to 4 pi over 4, which is 1 pi. So yeah, the period length is pi. So that's got to be 2 pi over B. And this is how we find our B. Period length, whatever that is on the graph, equals 2 pi over B. You rearrange that equation, and you get this. So B is 2. Okay, so cancel off your pi there and pi there. You left with 2. B is 2. So let's write that down. B, 2. With me so far? Okay. It's as easy as that. No big deal. So C, all right, well, they tell you on the graph, hey, look at this is C. Now, why do they put that there? Because if we're talking about a sine graph, you need to kind of locate a sine graph on here. And here is the sine graph, right? There's the shape of the sine. Goes up, goes down, and all that. Now, this is where there can be multiple answers for this, because actually there's several equations you can plug in here. Well, actually, there's an infinite number, but you can. There's 2 or 3 real major ones that you might come to. You might look at this and say, hey, Mr. Maxwell, I don't agree with that. I'm not going to have a phase shift at all. I'm going to start here. I'm going to go down, and I'm going to make this a negative sign. Well, there you go. You could have a negative sign version of this graph, because that is starting at 0, and it's an upside down sine graph. So that's negative sign. Yeah, totally. But if we wanted to make it a positive sine graph, you'd have to say, all right, Mr. Maxwell, here's a positive sine graph starting here, going up. So I'm going to shift it to the left for my C value. I'm going to do that. Totally fine. That actually works. Okay? I think what I'm going to do is, because they put on the diagram here that a C value is this right here, I'm going to go from 0, where it would normally start, and I'm going to go to the right. Okay? So I'm going to use my C value, which is really just the displacement here, right? It's just the phase shift. And what is it? From 0 to, what is this? Pi over 2. So the C value is pi over 2. Now if I want it to move right, it's going to show up as minus pi over 2 in my equation. Okay? But actually, positive pi over 2 in the equation is actually going to work too. Just the way it works. Alright, so that's C. Now D is the vertical displacement, right? And so normally sine would start at 0, but here obviously the center line is not 0, it's at 1, so we have D equals 1, positive 1. Alright, so you put that all together, and you have y equals 2 sine. Now, brackets, you'll see it in the book a little different way, I think, but you can do your b value just right there, and then you should put your variable and your c value inside these brackets here. So sine 2, and I said theta minus pi over 2, okay, and then plus 1. So there's your a value, your b value, c value, and d value. Now, I have the answer down here. Let's make sure that's the same. Okay, yep. I'm going to spring that on you later. Okay. Now, that's maybe a bit trickier than just graphing one that you're given, but I don't know. Maybe it's not. Might be pretty close to being the same there. Any thoughts or questions? Can you take a picture of this right here? Sure, go ahead.